Hey, what's up, pre-calc students? We're just going to continue on with these 4.2 part 2 notes. So let's just go to problem number 5 here. And we're going to just draw the angle whose measure is negative 2 pi over 5 radians. So the idea is just knowing that this would be 0 radians. So if I just start my angle here and I don't move at all, that would just be 0 radians. And we know halfway around 180 degrees is pi radians. So I see that denominator being 5. I probably want to call this 5 pi over 5. And our mission is to draw an angle whose measure is negative 2 pi over 5. So you have to imagine we're going to be going this direction because the angle is negative. And if you think about it, halfway from 0 to 5 pi over 5 would be 2.5 pi over 5. So we only want to go 2 pi over 5. So we're going to go just a little before we hit that y-axis. And that would be a pretty good estimate of going negative 2 pi over 5 radians. So that would put us in quadrant 4. And then for number 6, I see the denominator is at 2. So let me just call this 2 pi over 2. This would be 0. This would be 1 pi over 2. This would be 3 pi over 2. Now we want to get all the way to 7 pi over 2 radians. So we're going to start here at 0. We're going to go in the positive direction. We can actually just count this out if we want. So if we just start spinning, that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. That brings us right to this y-axis here. So we're going to give this an extra loop just because we had to go one full trip around, and then a little more to get us there. And since we're stopping on the y-axis, that's not actually in a quadrant, so we'll just say none for that. All right, moving on to problem 7. So what we're going to do is first draw 7 pi over 10 radians, and then we're going to answer a couple other questions after that. So why don't you pause the video so you can just set that up on your own and just figure out what quadrant you should be putting in, and we'll check it out in a second. Okay, welcome back, y'all. That should put you in quadrant 2. So notice I called this 10 pi over 10 because that just simplifies to pi. And then up here would be 5 pi over 10. So we just have to go a little beyond 5 pi over 10, and that would be in quadrant 2. All right, part B. So that was part A, mission accomplished. Part B, want to find a positive coterminal angle for 7 pi over 10. So what that means is, imagine we went 7 pi over 10 in this direction, and we wanted to get a coterminal angle by just taking one full trip around from there and bringing us right back to that same line. So to make that happen, we got to take that 7 pi over 10 we've already traveled and add 2 pi to it because there's 2 pi radians in a complete rotation. So to add that, we're going to have to rewrite this so that they have a common denominator. So I could call it, plus. So I could call this 20 pi over 10, since that's equal to 2 pi. Now I could add them together and call that angle 27 pi over 10. All right, so part C wants an example of a negative coterminal angle for that. So rather than adding 2 pi to it, we'll just subtract 2 pi from it to go the other direction. All right, so why don't you pause the video, see if you can compute that one, then we'll answer part D. Okay, welcome back. So just subtracting 2 pi from that should take you to negative 13 pi over 10. You can just leave your answer like that. And then for part D, we want a general formula that would find all the coterminal angles for 7 pi over 10. So when we're working with degrees, we add multiples of 360 to it to get the coterminal angles. In radians, we're going to add multiples of 2 pi. So we can just say it's 7 pi over 10 plus 2 pi k where k is an integer. That means if you put a negative number for k, you'd be like subtracting multiples of 2 pi, and that would give you negative coterminal angles. All right, so now what we're going to do is just come up with a formula for arc length. So what we have here is a picture of a circle. R would represent the radius of the circle. S would represent this distance along the perimeter of the circle. That's called arc length. All right, now when we were working with the Twizzlers, we defined the radian measure of theta, so what theta is in radians, to be the length of the arc, which is S, divided by the radius, which is R. So for example, if R had a length of 1 Twizzler, right, and S had a length of 3 Twizzlers, 3 divided by 1 is 3, means the radian measure of this angle would be 3 radians. All right, but we want to rearrange this so we have a formula for arc length. So since S represents the arc length, I could just multiply the R to the other side, and that'll lead us to our arc length formula. So we can box that. Nice easy one, just radius times theta, but please star this, only works if theta is in radians. So you cannot plug a degree measure in for that theta, it will not work. All right, so we're going to move on to example 8. So what we want to do is find the length of the arc of a circle whose radius is 3. So we can write down our radius. And it's subtended by a central angle of 140. So they're giving us the measure of the theta in degrees. And what we're trying to do is find the length of this arc. So the S is the question mark. So if they give us the theta in degrees, our first job is to convert it to radians, like we were doing the other day. So why don't you guys pause the video, see if you can convert that. Leave your answer in terms of pi. Don't make a decimal out of it. And we'll check it out in a second. Okay, so if you reduce that correctly, we should get 7 pi over 9 as our radian measure. So now we can get the arc length. So my arc length is just my radius multiplied by my theta, which has to be in radians. So we'd be doing 3 times 7 pi over 9. Now I could reduce the 3 with the 9, just make this answer 7 pi over 3. So when you write the arc length, we could write it 2 ways. We could say it's exactly 7 pi over 3 inches, because if the radius is in inches, the arc length's in inches. Or we could put that into a calculator, and that should come out to 7.330 inches. So that would be the exact answer. That's the approximation. That kind of makes sense, because if this distance is 3, I can believe that this distance is about 7.330. Makes sense to me. Okay, we're going to actually go through problem 9 together when I see you guys in class. So if you hop down to number 10, this circle has all the important angles that we're going to encounter in this class from now until the end of the year. So what I'd like you to do is pause the video and just write all the radian measures for each angle on the lines. Now we did this on this front page, but we did it in 2 separate circles. But I want us to just combine all these radians into one location so we have it in one circle. So just pause the video and see if you can get that on there. Eventually you guys will start to remember these and it won't be a big deal. Okay, yeah, just make sure you have them written correctly. I guess that's it for this video. Talk to you guys next time. Toodles.